Good morning, students. I hope you can hear me. So we were talking about the complete randomized design. And when you have a one factor in complete randomized design, how to use one-way ANOVA table to do your analysis. So yes, with the yesterday's example, I hope you understood that when we were conducting one-way ANOVA, what you have to do is like we can compare the treatment effect, or we can compare the treatment mean, and we can check whether there is any difference between our treatments. So when we use one-way ANOVA, what we can do is we can only get into the conclusion that whether there is any difference between treatments or not. That is the only conclusion that we can get. But if we want more details about the treatment means, so if we want to check now, when we conduct one-way ANOVA, if we reject our null hypothesis, that is, if we get into the conclusion that our treatment means are different, then we have to find out what are the differences, what treatment means are equal and what treatment means are different. In that case, there are many testing procedures that you can follow to find out these differences between treatment means. So one method is known as this Duncan's multiple range method. So in this case, this is known as MRT. So what we do is basically when you have a one factor CRD, so we check the mean, the treatment mean values, and then we compare those values with the standardized error of the mean for each treatment. And then what we do is we can find out by conducting this test, we can find out what treatment means are different and what treatment means are equal. So in that case, in order to conduct this test, the first thing that you have to do is, your first step, you have to calculate the mean value for each treatment like we did yesterday. And after calculating mean value, what you have to do is you have to rank your mean values from largest to smallest. That is the first thing that you have to do, right? So first you have to arrange, you have to calculate the mean values of the treatments, and then you have to arrange them in descending order from largest to smallest. And then what you have to do is you have to obtain the standard error of the mean for each treatment. Now, all the designs that we discussed so far, in those designs, what we had equal number of replicates for each treatment. So if that is our case, you get the same value for the standard error of the mean. So what you have to do is we have to read the mean square error value from the ANOVA table that we construct for this CRD and divide it by the number of replicates that we have under each treatment. That is, if you have equal number of replicates for each and every treatment, and then you have to take the square root value. But there are some cases where you have different types of replicates under each treatment. So in that case, you can replace n by this expression and find out the standard error of the mean. But in most of the cases that we are going to study, we are going to study about the balanced complete CRDs. That is, we have equal number of replicates. And then what you have to do is, after that, we are going to read a value from this Duncan's table. So I will show you the table. See, this is the Duncan's table. So this table has been constructed for different alpha levels. Now, since we are using alpha as 0.05. These are the values that you can use for alpha. And in this case, you can see you have degrees of freedom and you have P. So the degrees of freedom is equal to the difference between the number of observations in your full study and the treatment levels. So that is, if you have considered 100 units, 100 experimental units in your study, and let's say you have only 10 treatments, so 100 minus 10, 90 would be your degrees of freedom. And if you take this P value, this is actually now what we are going to do in this case is we take, at each time we take two means and compare. So when you take two means, so at the beginning, what we do is we rank all the means and we arrange them from largest to smallest. So when you arrange these mean values from largest to smallest, what you can do is you can check the rank values of the means that you are comparing, the two rank values, and the largest rank value is equal to this P. For an example, now let's say here, let's say when you compare these means, let's say the mean values are equal to 12.5, let's say 11.8 and 10.6 and let's say 10.4. So let's say you have 4 means in this particular study. So now I have arranged them in descending order from largest to smallest. So if we just check these, the rank values of these means, now here we can give number 1 to the first one since it's the largest. And then we can give the rank as 2 for the second mean. And then we can give the rank as 3 for the third mean. And then we can give the rank value as 4 for the last mean. So in this case, if you compare, let's say that you are going to compare first one 12.5 and the last one 10.4. In that case, if you are going to compare these two and if you check the rank values, the first 12.5, its rank is 1, and when you compare 10.4, its rank is 4. So when you compare the two rank values, the largest rank value is equal to 4. So in that case, you can take P as 4. So let's say when you take two consecutive observations, two consecutive mean values, when you take 12.5 and 11.8, in that case, you can take, when you compare these two, the rank of the first observation is 1, the rank of the second observation is 2. So the largest rank is 2. So you can go for 2. So this is actually when you compare the means, when you take the means, which is when you arrange all the means in descending order, and when you compare the two means with the same order, you can consider P as the largest rank value. But if you just take, let's say, you can compare, yes, now if you compare the first one and the third one, that is if you compare 12.5 and 10.6, in that case you can see again the largest rank is equal to 3, right? So you can take the p-value as equal to 3. But if you compare like this, 11.8 and 10.6, the two consecutive points, in that case, you have to always take p-value as equal to 2. So you can just remember this with the rank position. So what you can do is you can just check the gap in between the two mean two means that we are comparing. For an example, if you are going to compare the first two mean values, since the gap between these two mean value is 0, the smallest number that you can assign for P is 2. So if the gap between these two the two means that you are comparing is 0, P should be equal to 2. So if you are comparing 12.5 and let's say 10.6, then there is one mean in between. So the gap between these two mean values, that is equal to 1. So the next possible value for P is after the smallest is 2. That is when the gap is 0. So when the gap is 1, it should be equal to 3. Right? So in this case, if you have 4 mean values, in this particular example, since you have 4 mean values, you can compare any two mean values, which are any two consecutive mean values. In that case, the gap would be always equal to 0. So that is, for P, you can take 2. P is starting from 2. And then if the gap is equal to 1, if you have one observation in between the two means that you compare, you can take it as 3. And if you take the gap in between two means you compare, if the gap is equal to 2, for an example, if you compare 12.5 and if you compare 10.4, so with 12.5 and 10.4, you have two values in between, right? So if you have two values, then the next possible option would be for P4. So do like this. When you want to find the possible values for P, just first check what are the values that you can get when you compare two means together. So when you compare two means together, when you consider about the gap, you can have 0 observations in between. That is when you compare two consecutive means. And if you compare another two means, then you can have only one observation, only one mean in the middle. So you can have 1 as the gap. Then you can have 2 observations in the middle when you compare 2. So that is, you can have 2 as the gap, but that is the maximum gap that you can have based on this example. That is when you compare this largest point, largest number with the smallest, you can have the gap as 2. So that is the maximum number that you can get for your gap. So then you can assign the values for P. When the gap is 0, the smallest value that you have to start for P is 2. So it should be 2, 3, and 4. So that is P. So based on this, your degrees of freedom and your P value from the Duncan's table, we have to read the table value. For an example, let's say for this particular study, you have 10 treatments, and then you have the capital N is equal to 100. Then your degrees of freedom would be 100 minus 10. That is 90. So if you are going to read, let's say R value, where alpha is equal to 0.05, and let's say P is equal to 2, and then degrees of freedom is equal to 90. So if you look at the Duncan's table, now this is anyway for the alpha value 0.05. So in that case, what you can do is this is degrees of freedom 90 and P value is 2. So you can check the degrees of freedom column, that is equal to 90, but 90 is not here. So the most closest value for 90 is 100. So you can read 100 and 2 for P. So that is equal to 2.8. That's how you read this table. So then you read this value from the Duncan's table. Then what you have to do is, after reading this value, you have to calculate the least significant ranges. We denote this by RP. So this least significant range means this is the value that we are going to compare our mean, the difference between our mean values. So what you have to do is you have to calculate this RP value. So RP value is you have to take the table value and multiply the table value from the standard error of the mean. So the standard error of the mean we calculated at the beginning. So you have to take the standard error of the mean and then you have to multiply that with the table value. So then what you have to do is then we calculate the difference between two pair of means. So when you consider that, you have to always take the difference between the largest and the smallest. That's how you do. So then if this difference between these means, if they are greater than this least significant range, then we don't consider that. But if it is less than this least significant range, then we have to consider that value. So I will show you all these steps using one example. So the example that we already discussed yesterday, where we use the ANOVA table to do our analysis. So I'll take the same example and show you how to conduct this. Okay, so can you all see my Excel?
Yes, madam.
Okay, so first thing that you have to do is now this is our data set. If you can remember, yesterday we discussed we had 5 treatment levels, and that is the cotton percentage, and for each treatment the strength was our observation. So we have 5 replicates under each treatment. So what you have to do is first you have to calculate the mean value for each treatment. So this is my 5 mean values that I have calculated under each treatment. So here, now when you're going to compare the means using MRT, the first step is you have to consider that you have to calculate this treatment mean values, and then after calculating the treatment mean values, what you have to do is you have to arrange them in descending order, that is from the largest to the smallest. So in this case, the 21.6, 17.6, 15.4, 10.8, and 9.8. So when you are doing this manually, this is how you have to do. So you have to arrange them from largest to smallest. So here I will just put the rank of these means. Now in this case, these are the ranks. This is 1, 2, 3, 4, and 5. So we have arranged them in largest to smallest. So after arranging them in largest to smallest, now we have to read the table values from the Duncan table. So when you read the before that, let's calculate the standard error of the mean. So here, when you calculate the standard error of the mean, what you have to do is you have to consider the square root. This is actually, I will just write the expression first. That is the square root of, you have to take the mean square error value from your ANOVA table and divide it by n, since you have equal number of replicates for each treatment in this example. So here, that is, you have to take the square root value. MSC, if you just check our ANOVA table based on the previous example, you will see MSC, the mean square error is 8.06. So we have 5 replicates under each treatment. You have to divide this by 5. So this is the standard error. Now we have to find out. First we found the means, and then we arranged them from largest to smallest, and then we calculated the standard error. So you have to, if you're going to do the Duncan's test, first you have to actually calculate, construct the ANOVA table and check whether the treatment means are different, right? Then only we have to do this test. If the treatment means are the same, then we don't have to do further testing to find the difference. So in this case, so after finding the standard error of the mean, then the next step is we have to find the table values. So to find the table values, so alpha is, we consider alpha level as 0.05, and the degrees of freedom, now in this you have 25 observations and 5 replicates for each level. So that is degrees of freedom mu is equal to 25 minus 5. That would be 20. So from the table, you have to read 20, right? And let's check what are the possible values that you can get for P. Now, when you compare any two consecutive means, the gap is equal to 0. If the gap is equal to 0, I told you the least value or the smallest value that you can consider for P is 2. So when the gap is 0, you can consider P as 2. But when you compare two means with one mean value in between, so gap is 1, so then P is equal to 3. Let's say you are going to compare 12.6 and 10.8, then the gap is 2 means in between. So in that case, we can take P as 4. And in this particular example, if you compare 21.6 with 9.8, then 3 values can be in between, right? So that is gap is 3. So the value, the possible value for P, you can write as 5. So the possible values for P are 2, 3, 4, and 5. That you can find out using, by looking at the gap, you can find out the P values. Now, after finding out these values, now we have to read the values from the table. So that is, we have to read the R value where alpha is 0.05 and where the P value is 2 and degrees of freedom is 20. And then we have to find the R value when P is equal to 3. And then we have to find the R value when P is equal to 4. And then we have to find the R value when P is equal to 5. So these are the values that you have to find from the table, right? So I will show you the table values. So I will show you the table values. Let's check the table values now. So here degrees of freedom is equal to 20. So you have to read 20 from here. And then the P value, let's say, see when P is equal to 2, now here alpha is anyway 0.05. So when P is equal to 2, it's 2.95. When P is equal to 3, that is 3.1. When P is equal to 4, 3.18. When P is equal to 5, 3.25. So that is when degrees of freedom is equal to 20, we can find the values from our Duncan's table. Okay. And then back to our calculation. Right, so I'm going to, so you now just now I showed you how to find the table values. So just put the table values here. So when P is equal to 2, table value was 2.95. 2.95. And when it's table P is equal to 3, it's 3.1. And then when it's P is equal to 4, that is 3.18. And when P is equal to 5, that is 3.25. So we have these table values. That is our step 3. Now we rank our means from largest to smallest. We calculated the standard error of the means, and then we read the table values. So after reading the table values, what you have to do is you have to calculate the least significant ranges. So to calculate the least significant ranges, what you have to do is you have to take the table value and multiply that by the standard error of the mean. So that is, now since when you check the possible values for P, it can go from 2 to 5, right? So it can go from 2 to 5. So the least significant ranges we denote by RP. So in this case, P can go from 2 to 5. So we have R2, we have R3, we have R4, and we have R5. So let's calculate this least significant ranges, right? So R2, what you have, how you calculate, you have to take the table value when P is equal to 2, that is this one, and multiply that with the standard error. So R3, how you calculate, you have to check the table value when P is equal to 3, it's 3.1, multiply that by the standard error. And R4, you have to check the value when P is equal to 4, multiply that by the standard error. R5, take the table value when P is equal to 5 and multiply that by the standard error. So now we have found the least significant ranges. Right, so you can calculate the least significant ranges using this formula. So after calculating the least significant ranges, then now we have to do the comparisons. So when you're doing the comparisons, you have to always start with the largest mean value. So if you just compare the largest mean value, here the largest mean value is 21.6. Okay, so in this case, I will just write down the treatment here. That is the treatment with respect to the mean values. So here I will just write the treatment. So let's see. So 21.6 is coming from fourth treatment. So that is number 4. Then 10.8 is coming from fifth treatment. So this is treatment number 5. And 17.6 is coming from the third treatment. And then for the first treatment, 9.8, second treatment, 15.4. So 15.4, that is second treatment. And then 9.8 is from the first treatment. So we have the treatments. Now you can see when we rank these values from the largest to smallest, you can see the the largest rank is for the fourth treatment. So in that case, we always start comparing the means from the largest. So that in that case, what you have to do is you have to take the largest mean value and compare that mean value with all the possible means which are less than that mean value. For in this case, when you take 21.6, that is the largest, all the other remaining mean values are less than 21.6. So what you have to do is you have to compare 21.6 with 17.6. And then you have to compare 21.6 with 15.4, 21.6 with 10.8, likewise. But when you do these comparisons, you have to start from the largest, and also you have to, when you compare the order of the comparisons, you have to always start with the largest and the smallest value. So in this case, when you take 21.6, you can compare 21.6 with all the 4 remaining mean values, and the smallest is 9.8. So first you can compare 21.6 with 9.8. And then you can take 21.6 and compare that. The next smallest value is 10.8 with 10.8. And then you can take 21.6. The next smallest value is 15.4. You can compare that with 15.4. Then again 21.6. The next smallest value is 17.6. You can compare like this. Okay, so here we have all the possible combinations with respect to treatment 4, since it's the largest. So in this case, if you just check the treatments that we compare here, that is, here we always compare treatment 4 with other levels. So here we have treatment 4 and 9.1 is treatment 1, 10.8 is treatment 5, 15.4 is treatment 2, and 17.6 is coming from treatment 3. So actually we are comparing treatment 4 with treatment 1, 4 with 5, 4 with 2, and 4 with 3. So what you have to do is, now these are the treatments. This is the treatment levels. So here you have to calculate the difference between these treatment means. So that is, you can take 21.6 minus 9.8, and then 21.6 minus 10.8. Likewise, you can calculate the difference between these two mean values. So you have the difference like this. And now what you have to do is, now when you compare these differences, now we have to compare these differences with the least significant range. So this is the least significant range value that we calculated, least significant range values. So in this case, when you take treatment 4 and treatment 1, so in between, let's say treatment 4 and treatment 1, you can see in between you have 1, 2, 3 gaps, 3 means. So if you have 3 gaps, p-value should be equal to 5 as based on this example. So in that case, what you have to do is you have to compare this one. You have to compare this difference with R5, since P is equal to 5. So in this case, if you check treatment 4 and treatment 5, when you check treatment 4 and treatment 5, here treatment 4 is here, treatment 5 is here. In between, you have only 2 mean values. That is, P should be equal to 4. So that is, you have to consider this. You have to consider R4 to compare this. Likewise, if you compare treatment 4 and treatment 2, Here treatment 4 is here, treatment 2 is here. In between you have only one mean value, one gap, that is R value should be equal to R3. So when you compare treatment 4 and 3, so in this case 4 and 3 are consecutive mean values, so the gap is 0, so the P is equal to 2, so you have to compare this with R2, right? Now let's see what will happen. Now the first difference is equal to 11.8 and R5 value is equal to 4.12. So 11.58 is greater than this R5 value. So then you have no problem. Let's compare the next one. R4 value is equal to 4.03. And here the difference is equal to 10.8. Again, its difference is greater than R4. Here R3 value is 3.9, but difference is 6.2. Again, difference is greater than R3, so no problem. And in this case, if you take R2 is equal to 3.7, but the difference is 4. Again, the difference is greater than our calculated R2, so we have no problem. The mean, when you compare the mean level 4 or the treatment mean for treatment 4 with other levels, there we can say the difference is not significant. If the difference that you calculated here is greater than this significant value, we can say that difference is not significant. So here we considered the treatment 4. That's because you have to always start with the largest mean value. So then if you consider the next largest one, that is 17.6. Now here you have to consider 17.6 with all the possible means which are less than that. That is, you have to take 17.6 with the smallest one 9.8, and the next smallest one 10.8, and the next smallest one 15.4. So I will write here the possible values. So that is, we consider the treatment 3, that is 17.6. You can compare 17.6 first with 9.8. It's the smallest. And 17.6, then you can compare with 10.8, the next smallest one. And then 17.6, you can compare with 15.4. Right, so here we are comparing treatment mean of treatment 3. Here 9.1 is first treatment, 10.8 is coming from treatment 5, 15.4 is coming from treatment 2. So let's calculate the difference here first. Difference between these means. You have to subtract the smallest from the largest. So in this case, you have the differences here. And now you have to consider the p-value. See, now you are comparing the treatment level 3 and treatment level 1. So if you check the ranks, treatment level 3 is here, treatment level 1 is here. In between, you have 2 observations. Right, so if you have 2 observations, that is 2 gaps. So p-value should be equal to 4. So that is R4 you have to take here. So likewise, if you compare treatment 3 and 5, let's check. Treatment 3 is here, treatment 5 is here. In between, you have only one mean, that is gap is 1, so p is equal to 3. So you have to consider R3 here. And then 17.6 with 15.4 here, they are the consecutive mean values. So the gap is 0, p is equal to 2. So this is equal to R2. Now you can actually check these values with the R values. R4 is equal to 4.03. So the difference is greater than R4, no problem. R3 is equal to 3.9. Difference is greater than that. Let's take R2. R2 is equal to 3.7, but the difference is 2.2. Now in this case, here the difference is less than the least significant range. So in that case, you have to consider that one as a significant difference. So I'm going to highlight this. That is, there is a significant difference in mean with the treatment level 3 and 2. That is the, so that one you have to note down, right? And now let's go back to our means. Now we compare this 21.6, we compare 17.6, then you can start with 15.4. So when you take 15.4, there are two values which are less than, which is less than that. So you have 9.8 and 10.8. So what you can do is you can take 15.4, the smallest is 9.8, and then you can take 15.4, compare with 10.8. So 15.4 is coming from treatment 2, and 9.8 is coming from treatment 1, and this is coming from treatment 10.8 is coming from treatment 5. So first you can calculate the difference between the means. So these are the difference between the means, right? So in this case, when you take 15.4 and 9.8, 15.4 and 9.8, you have only one mean value in the middle. So gap is equal to 1. So in that case, R is equal to 3. So you have to compare this with R3. And when you take 15.4 and 10.8, no gaps, that is gap is 0. So the p value is equal to 2. So you have to compare this with R2. Now let's compare. R3 value is equal to 3.9, gap is greater than that. R2 3.7, gap is greater than that, no problem. So here the differences are not significant. Now the last one, 10.8. 10.8 you have to compare only with 9.8. So that is, you take 10.8 and compare with 9.8. So 10.8 is coming from treatment 5. And 9.8 is coming from treatment 1. So here there are two consecutive means, so gap is 0. So that is, you have to consider R2. That is R2. So let's take the difference between these two means. Difference is 1. R2 value is 3.7, but the difference is less than R2. So in that case, this is also significant. Right? So you can see when we compare these mean values, we got 2 points with the significant differences. So the conclusion we can just make that there are significant differences between all pairs of means except this mean, the treatment 3 and 2, treatment 5 and 1. That is, when you conduct this test, if there is a significant difference here, that means those two mean levels are equal, right? So in this case, 3 and 2 are equal, 5 and 1 are equal. The treatment means for treatment level 5 and 1, and for treatment 3 and 2, they are equal, but the other differences are significant, because now when you conduct the ANOVA table, the conclusion that we get is all the means are not equal. There is at least one pair which when you compare the means which are not equal. So we need to find out the differences between the mean. So when you conduct this process, if you find a difference here, that is, if you can find the difference that we calculated, the difference between mean levels, if that is greater than this least significant range, that means those means are equal. So in this case, mean for the treatment 3 and 2 and mean for the treatment 5 and 1, they are equal, but all the other means are different. So as for the conclusion, you can write there are significant differences between all pairs of means except 3 and 2 and 5 and 1. So I will write here. There are significant differences between all pairs of means except 3 and 2 and 5 and 1. So this should be your conclusion. So we have found out, since there is here that these two levels are different, so that will indicate these two mean levels are the same. So that's how you conduct this Duncan's process in order to find out whether there is any difference between the treatment mean levels. Okay, with that, do you all have any questions? Do you all understand the calculation, or if you have any question, you can raise. So actually you have to do this by all yourself. Now I used Excel to illustrate, but in the exam you have to do this manually. I'll be giving the Duncan's table, so you have to do all the calculations manually by yourself. So if you want to do that, you have to practice this, okay? So not in Excel, write all the steps by your hand, and then practice when you're at home. Otherwise you won't be able to do it in the exam. You need to practice, right? Because some of the steps are a bit confusing, but if you have a good practice, it's very easy to conduct. Please raise if you have any questions. Okay, then if you have no question, let me share my note. So now when we get into the conclusion using the ANOVA table, that treatment means are different. So the next step is to compare these means and find out what are the differences and what means are the same. So that's what we did using this Duncan's test. And when you conduct that test, you can find out what are the treatment levels which are having equal means and what are the differences that you have. So based on the previous example, we saw the means for the treatment level 3 and 2 and 5 and 1, they are equal. So when it comes to this pairwise comparisons regarding the means, there are different testing procedures, as I mentioned. So one is this Duncan's method, or else here you can use this least significant different test to compare. So that is actually now in the exam also, it's up to you. If I ask you to check for the differences between means, you can use any test. You can use the Duncan's test, or you can use the least significant different test to get into your conclusion. That is up to you. Okay, so I think we'll discuss this testing procedure on Friday. So if you have no question, I'm going to wrap up the session, but please do practice and do all your calculations and come when you're coming on Friday. Okay, and I will upload yesterday's recording and the note today with this recording as well. Okay, then if you have no questions, I'm going to stop. Thank you and have a nice day.
Thank you, madam.